this is an important project, and
Yeah.
and I'm seeing more and more how GPT and large language models and machine learning can be a help, but not the only thing. We need the combination. And I'm glad to see that you've been making a lot of progress on implementation. That's really great.
Hey, we're learning a lot. We are
well, that's what it's all about, isn't it?
Okay, well, let's get started. And today, I mean, we're really going to get into the weeds of development and how the system works inside, and the way you can add pieces to it when you want to. And I wanted to start off by giving a lot of background, and I also wanted to say that as I found that a lot of people watch the videos of these meetings when I post them on YouTube, and so be sure to say intelligent things. No, that's not what I meant to say. Be sure to invite your friends to join, and we'll be able to grow the group and be able to invite more people to come and join.
How many people are you seeing watch a video?
Hundreds.
Really?
Yeah.
Wow, that's impressive. Great.
Yeah. So yeah, it's actually surprising for as what otherwise how otherwise dry these might be. Hello, Matei, how are you? Good to hear from you again.
Hello, I'm fine.
Good. Hey, I wanted to start off by showing a picture that well, I should start off by saying how we're going to go through. So I'm going to give a lot of background information, and then we can get into more of the weeds of what Yida and William are actually working on, and what questions they have and what successes they've had. And so if we start here, you see a screen over there?
Yes, we do.
Okay. Here's a picture. And the way the brain simulator works is, on one end, there's a brain simulator program, or optionally the Mac version of the brain simulator program. On the other end, there's the universal knowledge store, and it is identical whether you're, depending on whatever platform you're on. It doesn't care. And one of the things I want to say is that I am impressed that although there are some multi-platform problems, C# seems to absolutely run identically on whatever platform you put it on. The universal knowledge store is the graph. That graph, you could think of it as a graph database, William, but it's a graph of nodes and edges, which I call things and relationships, and includes inheritance and exceptions, so you can add properties or attributes to something higher up in the hierarchy, and these magically are perceived as part of the lower level things when you get to them. There's exclusivity, which is a kind of unique property that you can say that certain properties, like numbers, can only have a single value. So you can't simultaneously have 2 legs and 4 legs. You can only have one. I mean, you can only have one of the two.
So Charles, you're saying without exclusivity, a value can be really an array of values?
Exactly. You can say that this horse is black and white and brown at the same time, because colors are not exclusive of one another.
Okay.
But numbers are exclusive, so you can only have one value of those.
Okay, and I can imagine a bunch of complicated more things, like a forest has to have at least 2 colors, but no more than 10 or something. But you're not worried about the nuances of that right now.
Not yet.
Okay.
But that's what exclusivity is, and it turns out that it's actually really kind of valuable, that especially when you're trying to figure out if you're getting, I mean, you have to be able to know whether data is exclusive or not to be able to know whether or not new data you're getting is actually in conflict, because without exclusivity, everything is good.
Good. And in common sense, I guess we could say what are, the two numbers? There's one and there's more than one. Well, maybe there's zero, one and more than one, but yeah.
Right. We also have transient data. You can put in data that vanishes very shortly after, and this is not so useful for the factual information, but is very useful for the common sense, immediate surrounding sort of data and things that you see and things that you want to be able to, things that you hear, because you don't want to remember what the last sentence was for all time. You only need it transiently, and so you can assign a transient timing to relationships, and they go away by magic. It also handles weighted data that we kind of talked about.
Okay, wait. On this transient, so I remember talking to you in the past about a sort of a general degradation, over time. Birds fly, and that's not really transient, but we might say if we didn't use birds anything for 10 years, that might drop out, right? So is that
we
different?
haven't, that's a correct idea, but we haven't really implemented that, but all of the pieces are there to be able to do it.
Okay, so transient
but definitely
means...
what is there is the distinction between birds fly and this bird is flying, which is likely not to be true for very long.
Good. So when you're adding something to the UKS, you specify whether it's transient or not?
Well, what you specify is an expiration time on it.
Okay, good.
And so it can be as long lasting, and essentially static data simply has a forever transient time on it.
Oh, nice. I like it. Okay, great. I'm happy.
Weighted data we talked about. Also, we haven't, the system's got clauses. Anyhow, there's a whole boatload of stuff that hangs inside the universal knowledge store that organizes the data, sort of. But then we have agents, and in the software, these are called modules, but they are agents that typically do something and typically do it to the universal knowledge store. And in previous lives, we've created about 50 agents that do various things, like grab data from video or grab voice data or speak or what have you. And some agents talk only to the UKS, and some agents can also talk to the outside world. Some agents talk to other agents, but that is something we now want to discourage. That if you want an agent that talks to another agent, plant the data in the UKS somewhere and let some other agent find it in the UKS and act on it.
So even if an agent knows that I want to pass something to this other agent, they would put it in the UKS and the other agent would be listening to changes in the UKS?
Right. Exactly.
Okay, and I suppose that also, if an agent has to sign up for data, that means one agent can't spam another agent, because if it didn't sign up for it, it's not going to get it.
Exactly. And the real reason I want to discourage having agents talk to each other is that there's no standard for how agents can talk to each other. And so there's this proliferation of different things that you have to know about every agent in the system that got to be just too difficult for words.
That's excellent. And I also like it from the asynchronous standpoint. The agent doesn't have to be ready right now to take the data, but it's in its mailbox. So when it's happy and has downtime, it can go and check it.
Exactly. So given that the entire system works with agents in the UKS, the only thing that the brain simulator really does is it calls all of these agents. And every agent has a couple of standard functions like initialization and what I call a fire function. And the brain simulator calls them essentially on a polling basis. And the reason, and at the moment it calls them in a single thread, but there's no particular reason that the entire system isn't fully multi-threaded, that it can call all agents simultaneously and asynchronously, and they do what they can do and get done when they get done.
When you call the fire agent, does it take arguments?
No.
So how does the brain simulator pass data into an agent?
Doesn't. That's the brain simulator can write data into the UKS and then the agent can pick it up.
Oh,
But,
okay.
But you're saying, how do we write data into the UKS? Is one of the agents does it. So
okay. So one thing I could say about this graph to just make it easier, this picture, is draw some green arrows from the brain simulator to agents, right?
Yes.
Maybe not all of them, but some of them. Draw a direct run from the brain simulator over to the UKS.
Right.
All right. And draw a red arrow between two agents, or, circle with a red slash through it, and that would strengthen the point that you just indicated about agents not talking to each other. And then there would then the UKS doesn't proactively send anything to an agent, right?
Correct. Yes.
So, okay, but we can have an agent, like one of your agents, like that top agent closest to the UKS, there's a green arrow to the UKS, but then they say the second agent down, a green arrow to the UKS, and make it like a circle so that it can go and ask for data and bring it back into the agent.
Exactly.
Okay, so this would really crystallize what you've said in the last 5 minutes about the communication paths.
Okay, great. I think that's a good idea. And now what we're going to do is well, first, before I say that, agents can be written in C# or they can be written in Python. And that is largely interchangeable, except that the C# agents can be multi-threaded, where the Python agents at the moment cannot.
Yeah. Python has some problems with multi-threading, as
does
JavaScript.
Although I read in the spec that the next version is going to have a multi-threadable capability, but at the moment we don't. So what I want to do is to fire up the program, and now we'll talk and we'll show you some agents, and then we will build an agent to show you what's inside and what you have to do in order to create an agent. And so we stop the program. We start the program. Does it show up in the right window? Oh, it does. Isn't that amazing? Along the left-hand side of the screen, we have this list of modules, and this is simply the list of agents. Agents may have dialog boxes, and these all do, but they don't have to. And if they are in C#, you can optionally display or not display the dialog box. In Python, I haven't implemented that feature, but it would not be terribly difficult should we choose to, if it comes to be useful. But
okay, so I'm going to add to your great graph earlier. Is there's a pointer to a user, a round trip to a user from an agent, right? That's a dialog box.
If you like. Okay.
Yeah, absolutely, because we're talking about the I/O to the agents here. So having a user at the top of the screen and one agent, send something to the user, and potentially a user can type in a value that the agent can get back from the user. That's a big deal. So,
right.
Cool.
Now this dialog box, this agent says it is the UKS. But it isn't really. All it is the dialog box that displays the UKS content. And so it isn't actually the UKS. The UKS is a separate thing, but this sits on a little timer and updates itself with all of the UKS content as the UKS changes. And we have a little bit of content in here. Aquatic, fish, animals, farm animals, birds. And we'll talk a little bit about what that is. This is an agent that you type data here and it goes to GPT and it gets data from GPT, ChatGPT via the API, and it shoves it into the UKS. And we'll talk about that a little more in the downstream. But the first thing I want to do is to show you the mechanics of creating a module, and we'll first do that in C#, and then we'll do that in Python. So we'll get out of the program. And to create a module, and I should say this, I'm currently working, and William is also working on data on this GPT module. So this is my actual working process. If I want to create a module and I want to create it in C#, I'll right-click on modules and say add and say new item. And this is perfect in Visual Studio, but I don't know if it works in VS Code or not, but it probably does. And it's not that, it probably works in VS Code. But within this add, there are all these different things you might add. So you could go to C# items, but if we go to Visual C# items, there's a template here for a UKS module. And if we give it a name down here, and we'll call it Fry. It'll be the Fry module.
Uh-oh.
Yeah, well, it's not going to do very much. So you can't go too far wrong. And you click add, and it creates this Fry module and brings it up. And it includes the fire and the initialize and set up before save and set up before load. And this UKS initialize notification is in case this module needs some special characteristics in the UKS, like you need to have the thing where you're going to be looking for data or putting data, and here you can put in the commands that control that. This dialog doesn't have this module does not have a dialog box. If you want it to have a dialog box, we have to create it and be sure to give it the same name. And you have to come and edit all of the ones out. So I'm putting the name in for this thing. Fry dialog, add, and here's the Fry dialog. And this is the empty dialog box, and we'll put a button on it just to prove that we can. And I'm not going to talk about the guts of how to write C# WPF.
Yeah, that's okay. That's okay.
Kinds of things, but that.
Charles, can an agent have at most one dialog box for the user?
Yes. There are.
We can consider, doing an extension there.
But in the UKS,
it's not bad.
There is the ability to have multiple instances of the same dialog box. So you could use a tabbed dialog box and fool it into being multiple dialog boxes as well.
Yeah, that's it. Yeah, but an agent often will know, oh, I want to get this specific information from the user, or possibly this other specific information from the user, and directing the user's attention to which it wants. One way to do that is these different dialog boxes, but that's an extension. I'm just saying it would be nice to have at some point.
So if we now compile the program, having essentially built a null dialog box, in this menu of dialogues, there's now a Fry module. And if we right-click on the Fry module that we just added to the dialog box, we can do the show dialog, and here it is with its press me button that I put in a few bits ago. So that's all you have to do to create a standard C# dialog, a standard C# agent. And then you get to go to the fire function within the dialog box, within the module rather. I don't know why I keep saying dialog box. And essentially you can put whatever functionality you want within the fire, and it will be called periodically.
Oh, so you can set up fire at an interval.
No, it gets called. It gets called as often as the system can do it. If you want to have something happen on an interval, then within the fire command, you say, has a second elapsed yet? And if it has, then you do your thing.
Okay.
A little clunky.
Okay, that's okay.
Any questions on a C# module?
Well, I wanted to ask you the relationship between a module and an agent.
A module is an agent.
So why are you using two words for it?
Because historically the system was built around module.
Okay, fine. That's
now
fine.
People understand it better if it's an agent.
Great. I'm happy. Yeah.
Okay, now we're going to build a Python module. And to build a Python module is a little different. We scroll down here in the project, and under Python project, we find that there's something called a module template. And we haven't written the tool yet that might do this for you by magic. So what we're going to do is copy and paste module template. We're going to give it a new name and call it module fry.py. And here we are in module fry.py. And what we want to do is to replace view template with view fry, replace for occurrences, and we're done creating an agent in Python. Now, if we go to rerun the brain simulator, if we go to our menu, we'll find that there is a module fry.py, and we can add it. And in Python, you don't get a choice, as I said, about whether or not you see the dialog box. You always see the dialog box.
Oh, yeah, I was going to ask that. So it could be the case that the fire agent, the fire method chooses to show a dialog box or not. Is that true?
In Python?
Oh, okay. But I'm talking about, eventual design here.
Yeah.
The agent might
the agent at the moment doesn't decide. There is although it could, there is a show dialog method, and you can call it or not.
Yes, I think that would be a good idea, that the fire method is automatically called periodically, and the fire method decides whether or not it should show the dialog box.
Sure.
Yeah. Okay. That sounds good to me.
And so for those of you guys who know much more about Python than I do, we'll look at that Python file just a little more closely and say it's got a bunch of tkinter initialization stuff, and you put your widget creation stuff into the dialog. It has a fire method. Here I've put in dummy code that only executes whatever it's going to execute after a time delay. And these are the exposed functions. Initialization, fire, get hwind is necessary to make the dialog box appear properly in Windows. I don't know whether or not it exists in Mac land. And there's a close function.
Close to close the dialog box.
Yeah, well, it also closes out the agent, I think.
Oh.
Well, maybe not. I take it back.
Oh no. Okay, this is interesting. So an agent can die essentially.
Yeah, you can remove the agent from the operating process. And reasons that you want to be able to control which agents are running is you have many more agents than you as a developer can keep track of. And you really only want to be running the agents that you understand how to work. And so
okay, so
well, right now the view
a fire method on an agent could call the close, which commits suicide, right?
yeah,
But a user can also pick a set of agents to run.
yes, the user can pick the agents to run.
Okay, and then so there's a dialog box of all the agents, and you just go down and check which ones you want.
Exactly. And that's actually what we were seeing in the program. That list is this list that we've chosen off of this list.
Cool. Okay, so when the user picks an agent to run, the initialization method of the agent is called.
Right.
And it's now on a list to be fired periodically.
Yep.
Good.
Okay. A recent change that we had to make in order to get the UKS to work properly in these multiple environments is that first, the list of modules and the list of modules that are currently displayed is stored in the UKS as well. So within the UKS,
cool.
in the UKS, there's a list of available modules and the list of actual active modules and the list of attributes of the modules. So, for example, we have an active module called UKS, which is this one, and it has a relationship to the attributes that, yes, it has a dialog window. There's an expand all value, which tells you whether or not things are expanded. There's what root is, and that's this content. And if we look at, I mean, we don't have to go through here, but what is important to understand is that when you save and load the UKS, you're also saving and loading this layout of what agents is going to be running.
Yeah. Okay. And then it right now, is it set up as a single user system? I mean, there's just one user, they've got their own model of the UKS, and that's it. Is that?
Yes,
right?
That is how it is set up.
Okay. But you are expecting to extend that to be there's a shared UKS.
Exactly.
Okay, and then it would be the UKS may still store which are the active agents, but it will be per user which agents are active. Good. Okay.
Yeah. And right now the UKS is entirely RAM based. When you say save,
okay,
it saves itself to an XML file, but the XML file does not change. It's a snapshot. In order to get this to be multi-user, we have to invent a scheme where this appears to the operating system to be a file.
Yes.
Which is multiple user access is the easiest way to manage things. Now that file can be also in RAM for velocity reasons, but Windows specifically, and maybe other operating systems, are very hesitant to have different independent processes share RAM data, and I can understand that idea.
Oh, but if we have C# with multi-threading, then that can work, right?
The problem is one of privilege, that if you have real independent processes,
Yes.
they don't like to share RAM.
Yeah. Okay. Yeah. These problems are so hard to deal with. God.
Yeah, I think
Right.
I think in Unix
Well, I
like
mean, just
systems
at the
too.
support at the programming level and operating system level, Jesus, 2024, haven't we got this together yet? You know, the answer is there's no.
No. Was somebody else making a comment back there?
Yeah, I was
Or
just
question?
saying that in Unix like systems too, like Mac OS or Linux,
Yeah.
usually you don't have multiple processes access the same critical section in the RAM, so it's a bad
Yes.
idea. Yeah.
Yeah. And that's the key, one of the reasons that in this picture, there is always this program, because this program calling multiple agents, be they in C# or Python, means that the access to the UKS is always a single process. The process is, this process is who owns the data, and so you don't have the sharing security problem.
Can an agent tell the brain simulator something?
Not easily. It is
Not
set
normally,
up,
let's just say.
not
Yeah.
normally. It is set up only to tell it that it's closing, and it does this by asking if the window exists. So when the fire is called, if the window no longer exists, it throws an exception, and that is the information that it can send back to the brain simulator. So it's a little limited. So what I wanted to do now is we got 2 agents or modules actively being developed, and Yita's really spearheading one of them, and William is spearheading the other, although William's decided that the summer is a good time to take a class, with which an attitude with which I absolutely concur. And so he's got a little less time. And so I've been playing with that a little bit more. And the dialogue, the module in question is this one, and it goes to GPT and gets data. And essentially, you can ask it anything you want, and it will get data and throw it into the UKS.
So GPT is an agent.
Well, yes, this is the agent, and the agent talks outside to the outside world at GPT.
Yes.
So if I ask for the characteristics of a sphere, it comes back and says, a sphere is a shape, an object is a 3D. Examples of spheres are balls, globes, and marbles, and it has unique characteristics. No edges, and it's smooth. And that data has poured itself in over here, dot sphere. And I had to put in this dot because otherwise data coming back from GPT clobbered data that otherwise was needed. So data coming back
You're
from
doing
GPT.
an analysis of the prose that's coming back from GPT. Is that right?
Yep.
And you're pulling out what from that? Nouns?
It is parsing this data.
Yes.
And everything in that data, if it is syntactically correct, gets jammed into the UKS.
By syntactically correct, you mean what? Are you prompt engineering to return certain syntax?
Exactly. And
Oh.
a quick look, and this is the painful part of this process. Here's the prompt: provide common sense answer to the request of what is in this case, a sphere. Provide
Yes.
answers that are common sense to a 10-year-old, each answer formatted in this format. Individual answers can have no more than 3 values. And so the choices are, it does ISA, can, always contains parts with, usually contains parts, has unique characteristics, and examples include, and is part of speech. And
Okay. Very good, Charles. This is
well,
great.
I haven't been able to figure out, because obviously it doesn't return all of them. It only returns the ones it thinks are interesting. So we can say horse, and it will say a horse is an animal, a pet. It can run, jump, and neigh. It always has 4 legs, a tail, and 2 ears. And it has the unique characteristics of a long mane, hooves, and then we get an inconsistency of strong, which is not syntactically correct, but I'll simply jam it into the UKS because.
Oh, okay. So Charles, I'm very interested in what you're doing here, and I've done a whole bunch of prompt engineering too, so happy to help on this. And what where I think you're going with this is that the common sense knowledge base in UKS can be built from GPS, from GPT.
Exactly.
This
And
is
so,
gargantuan. This is the big issue that I have with the whole system, and it sounds like you've got a path here. This is excellent.
right. And so what, William wrote this segment where you can pass it a text file of words. And what have I got as a word set up here? Animals.txt. So, and it'll sequentially just jam all of these words at that request and run them. And let me give you an idea of that in process. So let's empty out the data. Oops, missed. So now I've got an empty database, and I'm going to load that file named animals.
Okay.
And then I'm going to run this file, and it goes off to, and it's done already. And we'll rerun horse just for laughs, because that says it did this in 9,600 tokens.
Okay.
And so that process took a couple of seconds and cost about a dime.
Yeah. Okay.
So,
and so what did it find out? I can't read the text, it's too small. Can you just tell me what information it grabbed? That's much better, yes.
Yeah, I have the same problem, you see. So I have this
excellent ability. Yeah, I have a font size increaser in DDE as well.
Right. So under unknown object, we have, for example, animal.
Okay.
And under animal, we have bird.
Okay.
And here we have chicken is a bird, eagle is a bird,
yes.
hawk is a bird.
Yes.
And here are the attributes of a bird: can fly, a bird can sing, a bird can build a nest, it has a beak, 2 wings, and 2 legs.
Wow. That's dynamite.
Isn't that fun?
Absolutely dynamite.
And so now this is entirely searchable, although this is something I'm also working on because it tends to get too much data. But
well, okay. Yeah.
Well,
but the point is you've got the data in a known definitive format.
Exactly, and
That's
it's
the big deal.
It's searchable 27 ways from Sunday.
Oh yeah, yeah.
So if I say dog, it says a beagle is a dog, but I can come over here and say beagle. And now I've got data that's associated with beagle. And here are three. Grommet. Grommet, I didn't know he was a beagle. Snoopy. And the relationships to beagle are that he has floppy ears, has short fur, and nose, a strong nose. Okay, it has 2 ears and 2 legs. And you can see, Yeet, are you watching? You can see a huge overlap between the data that it brought back for beagle and the data that it brought back for dog.
Excellent.
And the agent that Yida is working on will look for that data and consolidate it upwards into the hierarchy.
Absolutely great.
So that's what I call attribute bubbling, where it's going to say this guy's got 2 ears and dog has 2 ears. If I come down here, here's where the dog is, the relationships of the dog. Oops. And the dog has 2 eyes and 4 legs, and this has 4 legs. So this data is unnecessary because it will automatically be inherited.
Yes.
And so in the event we find that the beagle, the poodle, and the Labrador all have 4 legs, we can assume that it's the dog that has 4 legs, eliminate the relationship at that level, and add it at the higher level.
Okay, and then you might also want to introduce a new object that has just those characteristics, like, I don't know, dog or animals with 4 legs or something like that. Right?
Yes, that I see as a separate agent that I call automatic subclassing. That given that you have a number of things that have a shared set of attributes,
yes,
we've got to assume that maybe they form a class of things,
yes,
and we can build the class, and then we can upload.
Yes. Okay. Yeah. Not make presumptions about all dogs have 4 legs. It's just Labrador and Dachshund and stuff. Yeah.
Exactly.
Yeah. And this is kind of, you know, Charles, I think of this as kind of like knowledge compilation and optimization, right?
Exactly.
Optimizing compiler does.
Exactly. And one of the things that occurred to me is that inheritance and inheritance with exceptions is this huge data compression mechanism.
Absolutely.
And so Yida, I wanted to ask you, since we haven't talked, it's really since the weekend on how your bubbling agent is coming along.
Yeah.
What did you see in this data that there were things that you could be successful with?
Yeah, I think I can try adding them to UKS, just run a more complicated test than the toy example that I have now, and see whether or not it works, and if it does, how well it works. I can run a test on how long it takes to go through, say, 1,000 data points or something like that.
Right. And even now, by the way, I'm just going to double check here. This has this data structure that we have now has got 370 nodes, 370 things, which of course is peanuts. but there's actually a large amount of data. So what we've already done, but with the structure, is done a lot of data compression before we've done the real data compression.
Yeah.
And when Yita's agent runs, it's not going to eliminate any things or nodes, but it will probably eliminate a ton of relationships.
Mm-hmm.
I have a very simple demo. Maybe I can just go through that.
That'd be
share my screen,
perfect.
go through
If you're
that.
ready, I'm ready to see.
Nice. Okay. It's the same thing that I sent you before, but I just want everyone else to take a look at. You know. Okay, so I'm working with the UKS that Charles has been describing, and basically UKS has a set of API commands that you can look at. And so here I'm just looking at all the things in the initial state of the UKS. And the very simple example is if we tell UKS that Fido is a dog, and I should probably make the fonts bigger, right?
Yeah.
Good.
I say Fido is a dog, Spot is a dog. So now the UKS knows that dog is the parent to both Fido and Spot.
Mm-hmm.
And then I add attributes to Fido and Spot respectively. Same attribute. Fido has 4 legs, Spot has 4 legs. And then I would just look at the UKS again. So, this is just me kind of going through the data structure underneath. So before, you see that UKS has this many things, and this many, out of this many things, these are the ones that have children, and they will be the ones that are interesting because the attribute bubbling is going to be from children to their parents, right?
Mm-hmm.
Now, if since we just added Fido and dog and respective attributes to Fido and Spot, so now this is the things with children that we have, right?
Okay.
So this gets updated, and now if we look at the initial before the bubbling, if we look at the initial relationships associated with dog and Fido and Spot, we see that dog has child Fido, dog has child Spot, Fido has leg 4, Spot has leg 4. So all is good. And now going through, I can describe this algorithm a little bit more, but basically we have a threshold, and we look at all the things with children. So each of them is called a parent. And then if we look at each parent's children, all of their children, and then, there's some programming techniques involved here, but basically we're saying that we look at their children, and if these children have some attributes in common, and we count the number of children that share that same attribute, and if that number exceeds this threshold, which is, I have a count here, and if this count exceeds the threshold, then I'm going to say, add that attribute to the parent, and I'm going to remove that attribute from all the children. So if I run it, if I run the attribute bubbling, and then, before I'm looking at these things, and now I look at the same things after the attribute bubbling, and what I get is now dog has leg 4, and the has 4 legs attribute gets removed from Fido and Spot, as you can see.
Yep. Mm-hmm.
So
very nice.
That's it. That's the demo, and that's the idea that we're running with. And I'm just hoping to run it on a lot more data and see, where it crashes and how we can debug that.
Yeah, it looks great, Yita. Thank you. Now, a few extensions. I can't.
Well, before you go there, one of the things I wanted to point out is that when you write your modules in Python, you can run them on a more or less standalone basis, as opposed to C#, you can only run them within the context of the brain simulator. But a Python module, if you just run it, it runs, and you can set up the same dialog box, and it's really pretty handy for testing and debugging on an individual module.
I'm used to using Jupyter Notebook. To me, it's like a whiteboard thing that I just write down things, ideas on, and work it out. So yeah.
So what I want to say about your algorithm is, if we find, let's say something has 4 kids and 3 of them have one attribute and 1 doesn't, then we could put the 3 things up in the parent, and the 4th one is an exception, or could be an exception, right?
Right.
Meaning don't inherit this. Exception meaning don't inherit, right?
Yeah, well, there are a couple of things that we're going to find out as we do this. That is, if I tell you that these 3 dogs all have 4 legs, does that mean that the 4th dog has 4 legs and I haven't told you anything? And so the assumption is that it is likely that it is inheritable absent any other information.
Yes.
Well, the current way that the UKS is constructed is that if now we have the attribute dog has 4 legs, then if I add a new dog to dog, then automatically that new dog is also going to have 4 legs, unless we introduce a exception.
Yeah.
Right.
Yeah. This is great stuff. And I think if we're talking about psychology and language and common sense, it is probably the case that language has developed to call dog something that all dogs have in common pretty much, but penguins can't fly and stuff. There's a few exceptions, but common sense and human psychology don't dictate, but strongly suggest default values and common attributes and all that. And so, and I don't know if you can get this out of GPT or not, but it's something commonly known, and then we can make these kind of assumptions and mostly be right.
Yeah. And Yida, I wanted to let you know that the thought I had that was going to make this work possibly not as well is, and I saw this from looking at the data coming out of GPT, is that there are many things that have multiple parents.
Right.
And so if you find out that a dog has fur, does that mean that an animal has fur, a mammal has fur, or a pet has fur? Is it all 3, or is it just some? And there's a little bit, and all of this may prove to be completely irrelevant.
Well, the way that this algorithm works right now is that the common attribute gets bubbled to the most immediate parent, and that's every sweep through the UKS. Now you can say that the attributes now belong to dog, and if we run this algorithm again over the entire UKS, and if dog has 4 legs and horse has 4 legs and they're both animals, then in the second round that would get bubbled to the animal class.
Right. But what I'm saying is that the data structure supports multiple inheritance and multiple parentage.
Yeah, that's important. Yeah. There's 2 different meanings of multiple parents.
The problem is that if you're working with dog and dog has 3 parents, when you bubble the attribute to the first of those parents, that attribute is now gone from dog and won't bubble up to the other parents. And I don't know if that's even significant. It may not. It may be an entire non-issue when we put it on some real data.
Can take account of the fact that there's 3 parents and do them all in one fell swoop if you wanted to.
If it's
we'll have to find out if it's relevant.
Yeah, if it's the same iteration, then all the parents would get that attribute before anything is removed. So that's how it works now. Yeah, I thought about that. Yeah, but
oh, good.
Yeah, we don't really. Well, I'm actually not sure, Charles. Do we have a lot of multiple inheritance in the UKS right now, or?
Well, that's what I say. I was observing it in the Williams stuff,
Right.
the GPT data, that it was saying, I don't,
But the way that the UKS is set up right now, irrespective of GPT, does it have a lot of multiple inheritances, or is it mostly just hierarchy? Okay.
No, because we humans don't think in terms of multiple inheritances, and we may also want to write another agent that does its best to optimize those out. That I mean, if you say Susie is a girl and Susie is a teacher, those are clearly disjoint, and you have to maintain them both. But if you say Fido is a dog and Fido is a pet, you can always get rid of one of the two of those, because all dogs are pets, or all
I
pets
actually
are dogs.
disagree with that a little bit, and I suspect that Fry's may be thinking about the same thing, which is I do think that the human brain does a lot of multiple inheritances. I don't think the knowledge structure in our brain is a hierarchy. I think it's more like what Marvin Minsky calls a heterarchy.
Sure.
So I'm not sure if that's what Fry's saying.
Or a DAG is more the you know what a DAG is.
Right. No, what's a DAG?
Well, it has to do with this kind of multi-inheritance, but it all ultimately they all go up to thing. Okay, so we know that ultimately they'll all go to thing.
Right.
But like I was thinking, Susie is what, a student and a teacher or something. That's kind of multiple inheritance.
Exactly.
So, but they will converge at a certain point up the hierarchy, because both teachers and students are people. So they're going to kind of branch out, but then come back. And then it's tricky of which of the attributes go into which. Like, student is maybe a good learner, but maybe a teacher is a bad learner. Maybe a teacher just, dispenses knowledge and can't learn anything new.
Yeah. So what I want to do is, as we wrap up here, is Yida, I'm going to just save this data structure that I've got, because and email it to you. And then you'll have that attachment, and you'll see if you can load it and see if you can make it work. Are you working in Mac land or in a Windows box?
I just set up everything in Windows the way that I like it to be, so I can do Python dev from either Mac or Windows now.
Okay, and the only reason I'm asking is that the file I'm going to send you calls out a bunch of C# modules, which you may or may not have, and I don't think it's going to be a problem, but you should be prepared that it's not a problem. Okay, well, I'll get you that so that you can move forward with at least a few hundred elements. I'm still experimenting, and as soon as I try to add more and more elements, the GPT seems to be able to throw a wrench in the works to create some reason that the data is dorked. And I've also learned that you have to be really careful with it, because if the data gets dorked, I have to add some protection to the query functions, because the query functions are getting potentially ponderously slow if you have circular kinds of references that have to resolve themselves out. So I'm working on that. William, is there anything I can do to help you, except find you more time?
No, but I should be done in a few weeks, so I'll probably have 2 months off during the summer. So.
Oh, that'll be grand. Okay. Matei, do you have a question? I guess not. Hey, well, we're going to meet again in about 2 weeks. It's going to be a conversation that's a higher level. We've been in the weeds here in the code, but in 2 weeks, we'll talk about the philosophy of data and how your mind actually works and why. So we'll be talking about that too. So this is.
Let me say I have a concluding remark to make.
Sure.
This was a great meeting. I am so impressed with the progress here. It's colossal. Charles, you're connecting between GPS prompt engineering and UKS, brilliant. And I've done a whole bunch of work on prompt engineering. I'll talk to you about that. I've taken a lot of notes on this meeting. I will send them to you. Notes on the chart and all this stuff.
Fabulous. And be sure to loop William in on it if you can.
Okay, or you can transmit.
Or I'll
William,
forward it to him.
Your code that takes a list of nouns and does the right thing with the prompt engineering, also brilliant. That's a huge deal. And we can go meta on that. We can say, give me the 1,000 most common nouns from GPS, get that list, and then feed them back in to your process. So we can build up the UKS very, very fast here. Yeah. And Ida, your stuff on this fancy inheritance and all that stuff, that's the real smarts. This is just dynamite. I am so impressed, you guys. Great job.
Looking forward to doing more stuff on the knowledge representation front. You know, I feel like we're just getting started with the classification and hierarchies. We should build up to trans frames and things like that.
All kinds of inferencing can be done, and the smart code, you've got a template for inserting the smarts, and with the UKS, and now that I understand how data is getting passed around, I'm blown away. I don't know what else to say.
Well, that's grand. Okay, well, thank you all. We'll be talking again in a couple of weeks. Appreciate it. Appreciate all your time and all your good works.
All right.
Okay.
Appreciate it.
See you.
See you guys later.